In today's video, we are going to take a look at this vintage piece of equipment, and as obvious from the logo, this is a Philips. This is a Philips PA amplifier, and the model is EV6502/01, made in India. So we are now going to take the cover off and have a look inside. Before that, we will just take a look at the front panel. We have three knobs, one for channel 1, one for channel 2, and the third one is marked H. We have to investigate what H means. Also, there is a switch. Now we will open the cover and have a look inside. We have already opened the side screws, and we will be taking the cover off. So that is the view of the inside, and obviously, since this is a flea market find, the inside will be very dirty, and it is very dirty, as you can see here. A very large power transformer, about 4-inch high, and 3.25-inch wide. This is a very big power transformer, and also here we can see a can here, and it seems like a vibrator. Since the vibrator is present, this is a battery. This amplifier also works on the battery. So before we take a look at the tubes, we will just blow this with a air blower, and then we will continue. So this is somewhat clean now. We have removed the loose dirt, and you can see these two are the output valves, EL81. We have a ECC83 here, most probably serving as a preamplifier. Then we go here and we see another valve, then that is the ECC40, and this is another valve. I'm not sure what this is. We have to open this cover and then check what it is. And before we go and do anything else with this amplifier, we must check if this is the output transformer, and if this output transformer is okay or not. Because if the output transformer is faulty, then nothing can be done about this amplifier. We have to close this project. But if the amplifier output valve is okay, then we can proceed with the restoration project. So we have this is the secondary of the output transformer. We have connected two leads on this, and we have connected a speaker. This is a 3 ohm speaker, but this will work. And this is the primary side, and this is the primary side. One of the This is going to the plate of EL81, and there is another wire. This is also going to the plate of EL81, and this is a center tap. So we will connect a battery between the top and the lower contacts of this output transformer and see if we can get any output on the speaker. So we have connected a 9-volt battery uh, to the primary side of the output transformer. This leads connect The red lead connects to one of the terminal of the battery, and when we touch the other pole of the battery with this connector, then we can hear some noise on the speaker. So that means that the output transformer is working properly, and now we can proceed with the restoration project. So here is a view of the inside of this radio. So this bulb is faulty, it is not working. This says Philips 6.3 volt 0.25 ampere. I'm using this old capacitor, base of this old capacitor, and we are reusing this base to connect two new capacitors. These are 47 microfarad and 450 volt. So we will be connecting these two capacitors in place of the original capacitor in this amplifier. Using this drill machine, we have drilled two holes in this base. Now we have fixed the capacitor base on the amplifier chassis. And the new capacitors will be going in like this. So we were checking the circuit out of this amplifier, and we found that the selenium rectifier is faulty, and these two selenium rectifiers are connected in parallel, and we have checked and we found that both of them are faulty. At low voltages they are working, but as soon as we exceed the voltage of about 50 volts, they start leaking, and at about 100 volts they leak. There is complete leakage inside it. So these two rectifiers are faulty, and we have to change it. So we will be replacing it with a rectifier, silicon rectifier like this. And obviously when we replace selenium with silicon rectifier, the we have to add a series resistor to lower the voltage, uh, and we'll be adding about 180 ohms resistor in series to lower the main voltage. So this is the view of the inside, and these plates are the actual rectifier. They are connected in series. This is the actual selenium rectifier, and here you can see there are a lot of bubbles, which means that the selenium rectifier is faulty. This is the on off switch, and this was not working. And close observation, we found that the contacts, there was a carbon deposit on these contacts. So when we are switching it on like this, these two contacts are getting shorted by this uh, round thing. This is also metallic, so this is getting shorted, but there was a lot of carbon deposit on the contacts, and hence the it was not working. uh, this is off position, and this is on position. So we took it apart, we cleaned all the contacts, we cleaned the carbon deposits on them, and now it is working. We have attached one terminal strip there for connecting the newer components, the new electrolytic capacitors, and another terminal strip there for the same reason. So those are the two changes that we have made in the circuit. In addition to that, we have changed the another coupling capacitor here because that coupling capacitor was damaged. Original was damaged, so we have changed that. Other than that, all the components are okay and we need not change them, so we have kept it as it is to maintain the originality of the circuit. So electrical restoration of this amplifier is complete. Now we will cover the plate here with a plate like this. We will cover it up, and then we will attach the rubber feet underneath. These are not rubber feet, the plastic feet. The original were black ones like this one, but these are not available, so we'll be using these white ones. So we'll put the feeds there, and then we will cover the circuit. And so here the bottom plate is attached, and here is a view from the top of the amplifier. So in our next step, we are going to attach a dropping resistor. This is a 220 ohms 20 watt dropping resistor. We'll be putting it here. Since we have replaced the selenium rectifier with a silicon one, we'll be putting a dropping resistor. So we'll be putting the dropping resistor here with the help of some screws. And after that, we'll be concentrating on this top cover. We'll be removing the rust, and then we'll be repainting it with somewhat the same color as the original one. So that will be our next step. So now this is ready to be painted. It has been painted with primer now, and it will be painted with a gray color which we have ordered on Amazon. And regarding the electrical restoration, this is the last piece of restoration that was remaining, the adding a dropper resistor. And this is the 250 ohms dropping resistor which we have added in series with the selenium rectifier. The rectifier is not selenium right now, it is a silicon rectifier. So initially it was selenium, so since the silicon rectifier has been added, so we have to add a dropping resistor. So here is the dropping resistor, and here is a view of the overall amp. So the painting job is done, and it has been painted with gray color. As you can see, the paint has dried out well. So the next step is to put on the jewel light which was here, and after that we will put this cover on the amplifier, and that would conclude our restoration. So that concludes the restoration of our amplifier. The amplifier is working, we have checked it, though there is some possibility of adjustment because there is a background noise, and we need to check that. But for that I need a audio signal generator, which I don't have right now. So those adjustment and settings are kept for another video. But as for now, this restoration work is complete. So this is our restored amplifier, Philips EV6502, made in India in the year 1961. And here is a view from the back. Friends, the schematic of this amplifier was not available online, so I did some research and found that this model, which is made in India, is closely resembling with another German model. And here is this German model EL6611. So the Indian model, so in this model we have one ECC40, one ECC83 and two EL81. And in the Indian model we have two ECC40, one ECC83 and two EL81. So slight difference. We will see what differences we have in this German model and the made in India model EV6502 which we have. This is the schematic of the German model EL6611. And this is these two are the two halves of the ECC40, and the microphone input goes into the first section of the ECC40, and the pickup input goes directly to the second stage, the second half of the ECC40. So microphone input goes through two stages of amplification, and the pickup input goes only through one stage of amplification, and after the amplified signal is fed to the ECC83, and the ECC83 is configured. This section is configured, the first half of the ECC83 is configured as a common cathode amplifier, and the second half is configured as a grounded grid amplifier, and the signal is fed to the push-pull EL81 stage, and then we have the output transformer. So this is the basic configuration of the German model EL6611. The Indian model is very similar to this because the Indian model is derived from this. So it is very similar, and we will see the schematic of the Indian model now. The Indian model, here is the schematic of the Indian model. The Indian model has two mic inputs, whereas the German model had one mic input. The Indian model has two mic inputs, mic 1 and mic 2, and also there is a phono input. So the similar to the German model, the mic inputs goes through two stages of amplification. This ECC40 and this ECC40. Similarly, the second mic input also goes through two stages of amplification, ECC40 and another ECC40, and the phono input goes directly to the second ECC40. So phono input is going through only one stage of amplification. The amplified signal is again fed to the first half of ECC83. This ECC83 is configured as a common cathode amplifier. The signal is fed, the signal from the first ECC83 is fed to the EL81, this EL81, and this ECC83 is configured as a grounded grid amplifier. The signal goes from this cathode and then passes to the EL81 through this 68K capacitor. This is another EL81. So these two EL81s are in push-pull mode, and this is the output transformer. We have various tappings for 4 ohms, 8 ohms, and 100 volts. So this is the basic, this is the configuration, the schematic of the EV6502 Indian amplifier. The schematic is very similar to the German one, except that it has an extra mic input, and for that we have an extra ECC40. So since this ECC40 has two sections, another section is not even used. All the pins are soldered and connected to the ground. So a bit of wastage of resources going on here. You can see the two mic inputs, mic input 1 and mic input 2, and this is the phono input. And here are the various tappings for 0 volt, 10 volt, 13 volt, 18 volt, and 100 volt, which corresponds to 0 ohms, 5 ohms, 8 ohms, 16 ohms, and 500 ohms speaker. And this is the socket, the octal socket. Now the pin 4 and 6 are for the power. I have connected the pin 4 and 6 directly to the wall outlet. This is only a temporary adjustment. This is only temporary because I don't have an octal plug right now. So we will be powering on the unit, and then we will give a demo of this amplifier. Yeah, for demo purpose we will be using this speaker. This is a 80 ohms 40 watt speaker. So we have switched on the amplifier. You can see the indicator lamp is glowing. And for the signal source, we are using free music from my mobile phone. So now the music is going into the phono input. So when we now I am giving volume